Good morning and once again welcome to my YouTube channel Pearson and Excel International Maths by Mr. Kamotho. And today I want to introduce topic number 2 of Pure Mathematics 4, which is called partial fractions. And partial fractions, this is not new. We have heard of partial fractions in Pure Mathematics 3. But today I want us to learn a little further and understand more details about the partial fractions. And of course, if you read on page 7, we are on page 7, there is something that is explained there. Partial fractions are single fractions with two distinct linear factors in the denominator can be split into separate fractions with linear denominators. This is called splitting it into partial fractions. For example, we have been told that if we have, for example, 5 over x plus 1 multiplied by x minus 4, these are linear factors at the denominator. This one can be expressed in terms of a over a single denominator, x plus 1, of course, plus another b, which is over the other denominator, where a and b are a constant to be found. Well, the expression is rewritten as the sum of two partial fractions, the way you can see it. And we are told that there are two methods that that can be used to find the constants a and b. And the first method is by substitution. And the second method is by comparing coefficients, by comparing or equating coefficients, by comparing coefficients. Some books will talk about equating coefficients, others will talk about comparing, but I like comparing coefficients, and I tell you, you'll see why. And I want to directly go to example 1. Example 1. And we are told to split 6x minus 2 all over x minus 3 and x plus 1 into partial fractions by A, substitution method, and B, by comparing the coefficients. And we start by substitution method, and it goes without saying this is just going to be A over x minus 3 plus B over x plus 1. When it is this way, we just solve it normally, like getting the old LCM, x minus 3, x plus 1. And when you divide by any of these divisors, you of course get the other one. So here we are going to have A multiplied by x plus 1 plus b multiplied by x minus 3. And now that the denominators are equal, the numerators must also be equal. So we have 6x minus 2 being equals to a x plus 1 plus b x minus 3. And I think this is now the most important part of this topic or of this example, that we need to ensure that one of these bracket is nullified, is equals to 0, so that we can have fewer unknowns. And I would want to let you know that we can easily make this bracket 0 by letting x be equals to 3. When x is equals to 3, the whole of this will be 3 minus 3, which is 0, nullifying the whole of this term. And of course, 3 times 6 is 18 minus 2, which is 16, is equals to 3 plus 1, which is 4, 4a. And without further ado, you will see that a is equals to simply 4. And at that particular point, we have gotten our a, and we can try to get our b by nullifying the second bracket. And we can say, let x be negative 1. And when x is negative 1, you see that this is going to be minus 6 minus 2, which is minus 4. The whole of this term will be nullified, and there will be minus 1 minus 3 minus 4 minus this is going to be minus 6 minus 2, which is minus 8. Sorry for that. Negative 6 minus 2 is going to be minus 8. And of course, this one is going to be nullified, and we're going to have is equals to minus 4b, because of minus 1 minus 2 minus 4b. So it goes without saying that you can also say that b is equals to 2. So we can easily express this one in terms of 6x minus 2 all over x minus 3 multiplied by x plus 1 to be exactly equals to a, which is 4 over x minus 3 plus b, which is 2 over x plus 1. And that is just what we need to understand. We have made it happen. And that is by substitution. That is just by substitution. And we need to talk about comparing coefficients. Comparing coefficients with what do we have when we compare the coefficients. At the same time, we will just expand this expression until this particular point, and we're going to still say that the numerators are equal. So we will pick it at this level. We will pick it at this level and have 6x minus 2 is equals to, open this bracket now. We're going to have, okay, let me just ax plus a plus bx minus 3b. What happens here is that we collect all components that are having x, and we have 6x is exactly equals to all the terms that are having x, a plus b multiplied by x. So eventually, if you divide both sides by x, you'll find that 6 is equals to a plus b. And all the other constants are equal also. So we are also going to have minus 2, or because these are constant, this is a constant, and this is a constant, we can already see that minus 2 is equals to a minus 3b. And we have now simultaneous equations which we can solve. We can talk about this minus this. In fact, equation 1 minus equation 2, 6 minus 2 is 8, is equals to a minus a is 0, b minus 3b is 4b, and of course b becomes 2. If you substitute this b in this particular equation, we're going to have 6 is equals to a plus 2, and therefore a becomes 6 minus 2, which is a 4. So eventually you are still getting back to the statement which is telling us that 6x minus 2 all over x minus 3 x plus 1 is equals to a, which is 4 all over, because we are picking it from this particular point, we are picking it from here, a, which is 4 all over of course x minus 3 plus b, which is 2 all over x plus 1. And that is just like it. So two methods, substitution method and comparing the coefficients. Okay.